So compound inequalities. What is a compound inequality? What did we just learn about what is a compound inequality? From your intro activity. It's two inequalities that do what, Charlie?
I don't know. Just knows two.
They are connected with what two
And
words?
or.
An and or an or. Good. Okay, so a compound inequality is two inequalities put together with an and or an or. Or an or, right? So do a quick demonstration. If you own a cat, stand up. If you own a cat, stand up. All right, take a look around the room. Okay, have a seat. If you own a dog, stand up. Okay, have a seat. If you own a cat or a dog, stand up. So if you own a cat or a dog.
So stand up.
Oh, stand up.
So everybody who just stood up should be standing up.
Oh, stand up.
Right?
I have both.
Yeah. But so you have a cat or a dog, so you have one of the other. Right. So those who are up for the ors, that means you stood up for a cat and you stood up for a dog. Now sit down. If you have a cat and a dog, stand up.
So you have a cat.
You have a cat and a dog. So you stood up all the time. So why are there less people for cat and dog versus cat or dog?
They have both of them?
Right. It's more restrictive, right? It needs to be that they have both a cat and the dog. The cat or the dog, you could have had a cat, you could have had a dog, you could have had both a cat and a dog, right? Huh? You could have both. You just would get double counted when we find probabilities, but you could have both. Because you have a cat or a dog, right? If I said you win $500 if you have a cat or a dog, Cole, would you say I'll take that $500 because I have a cat or a dog? You would say yes, I will take it. Okay? So compound inequalities have ands and ors. So an and inequality, your and compound inequality, the solution is true of both. So the solution is true of both inequalities. And you have your and. So the solution has to be true of both inequalities. And this is just directly pulled off of the paper that is sitting in front of you from your UNH Wildcats. Okay, so when I see an and, I know that it needs to be true for both the inequalities that are occurring. The graph is the intersection of the two inequalities. Okay, so the graph is the intersection of the two inequalities. So it would look something like this, for example. If I had a graph with 1 and 3, it would be everything between 1 and 3. Right? So I'm looking for the intersection. That's what your and inequalities will end up looking like. Okay, so this would be values that are larger than x and values that are larger than 3. So 2 would be true. 1.1 would be true. 2.3 would be true. 0.9 would not be true, so it would not be greater than 1. It's on the outside of it. Okay? All right, so those are our and inequalities. Or compound inequalities. the solution is true for one or more
Ms. Poliquin and Ms. Nelson's classes go to the Learning Center, and you'll have second lunch today.
of the inequalities. Seems a little delayed. So your or compound inequalities would be the solution is true for one, and Cole, this is where the or more of the inequalities comes in. Right, because you were true for both the inequalities. So or is going to be true for one or more. When we think about the graph is what's called the union of the two inequalities. So when you think of the word union, you should be thinking like the marriage, the blending of the two inequalities. So lots of times when we have or compound inequalities, if I bring back that 1 and 3, you'll have something like this, where the shading goes in opposite directions. So it can either be in this inequality or it can be in this inequality. Sometimes I like to think about it as like I'm driving the oars of my boat. Can you see? Here's me, Mrs. Crowley, in my boat. There's my oars that I'm rowing. Can you see it? Row, row, row your boat. I don't. I have a canoe. I guess that counts, right? Does it look like oars? Paddling my oars? No? Sure? Okay. I tried. So oars go in opposite directions. So we're going to be using the word union. And keep that union word in your mind, because when we get into interval notation, it's going to become helpful. Okay, so can we see some in action? Okay, so I think the most difficult part of this lesson is going to be writing our answers in interval notation. So we're going to start with just basic compound inequalities, and then we'll start solving them. So we're going to graph the compound inequality, and then we're going to write our answer in interval notation. Bless you. So I have the interval of x less than 6 or x greater than 10.
You want us to graph it, right?
Well, we will. So if I have to be less than 6 or greater than 10, someone give me a number that would be a solution. Give me a number that's less than 6 or greater than 10. 11 would work. 4 would work. 3 would work. Any number that's less than 6 or greater than 10. 20 would work. Would 7 work?
No.
No. That would not work. Okay? So graphing it, let's see what that would look like. I'm going to put 6 on the left, 10 on the right. That's lazy graphing. Smaller number on the left, larger number on the right. Parentheses or square brackets. Parentheses. My parentheses is going to be facing to the left because I want to go less than 6 for my shading. I'm going to have a parenthesis at the 10 open to the right because I want to shade to the right. So now we have to think, how do I put this in interval notation? Well, this would be negative infinity to 6 with a parenthesis. This would be 10 to positive infinity with parentheses all around. And then instead of writing the word the word or, like we did in our intro activity, we're going to use this U for union. Because remember we said that or in a compound inequalities are the union of the two. So I am taking the union of this inequality and this inequality. So that's what your interval notation is going to look like with or compound inequalities. You're going to have the union of two inequalities. Think we got that? Okay, so instead of writing out the word you, you're putting, or the word or, you're putting the U for union. Okay, so we got that one. So let's see if we've got this one. So x is less than or equal to negative 1, or x is greater than or equal to 2. So x is less than or equal to negative 1, or x is greater than or equal to 2. So graphs help. So lazy graph. I'm going to put my smaller number on the left, my larger number on the right. At the negative 1, is it going to be a square bracket or a parenthesis? Square bracket facing the left, because I'm going to shade to the left. Square bracket on the 2 facing the right, because I'm shading to the right. So, interval notation wise, my left side is negative infinity to negative 1. Union, good. Square bracket 2 to positive infinity. And the reason why I like interval notation is you don't have to worry about your inequality signs and messing them up for your answers. Okay? All right, so we're good with ors. We can go to ands. All right, let's do some ands. So if I need x to be less than or equal to negative 1, and x needs to be greater than or equal to negative 5. So x is less than or equal to negative 1, and x is greater than or equal to negative 5. So again, if I were to make a graph of this, lazy method, put your smaller number on the left. Oops, smaller number is negative 5. Larger number is negative 1. So at negative 1, I'm going to have a square bracket facing the left because I want to shade to the left. And then I'm going to do a different color because I can. At the negative 5, I'm going to put a square bracket facing the right because I want to shade to the right. And my solution set is the intersection of those two shaded regions, which would be in between which two numbers? Negative 5 and negative 1, which makes sense because if I need to be a number between negative or less than negative 1 but larger than negative 5, it has to be negative 4, negative 3, negative 2. All of those would be true for both of those two statements. So for my final answer in interval notation, right here I see it, bracket negative 5, bracket negative 1. So my smallest number that it could possibly is negative 5. My largest number it could possibly be is negative 1. Okay? All right, so we've got our ors and our ands in interval notation. Now we can actually do some solving with them. Okay, perfect. Is everybody good? All right, so let's go ahead and solve some compound inequalities. So I was just making sure we could write our answers correctly. Now let's do the actual solving part. So we've got two inequalities. We've got a 2k minus 5 is greater than 7, or negative 3k minus 1 is greater than 8. So the only thing that's you have to do with or compound inequalities is you just have two separate inequalities you need to solve for. But you guys all are masters of solving inequalities, so let's work with the left one first. Graham, what would you do first to solve 2k minus 5?
Plus 5.
Perfect. So if I add 5 to both sides, we get 2k is greater than 12. And then, Skylar, what do we do next? Yep.
You do divide by 4.
Perfect.
I mean, not 12.
By 2. Good. I knew what you meant. So then we get k is greater than 6. And then let's just jump over to the right side and solve that one. So adding 1 to both sides gets us negative 3k is greater than 9. Dividing by negative 3, what must I remember to do? Flip it. So k is less than negative 3, and then I'm going to bring the or down. So, what would that look like on a graph? And the only reason why it's smart to graph it is it kind of helps you to see what your answer is going to look like. So my smallest number out of 6 and negative 3 is negative 3, so I'm going to put that on the left. My larger is 6. At 6, is it going to be a parenthesis or a square bracket?
Parentheses.
Open to the right or the left?
Right.
To the right. Perfect. Shading to the right. And then at -3, parenthesis to the left, shading to the left. So now let's put it in interval notation. Negative infinity to -3. Oops, -3. What do I put in between? Not or. U for union. And then 6 to infinity would be my final answer. Okay. So we're just doing double the work. Nothing too crazy. Jackson.
Would it be like other way around?
Always smallest to largest. So you want to always have the smallest inequality up to the largest inequality. Okay, good question. Okay, so that was an or. Let's do an and. Do I have, which ones do I want? Oh, nope. Okay, so sometimes your ands will look like this,
What does that mean?
where they have it just smushed into one line. So go ahead and write it, and then I'll explain it. So we have 4 less than n plus 6 less than 9. So this is where your and inequality comes from. So remember, our ands, we're looking for what is in between an endpoint and an endpoint, right? Bless you. So right now my endpoints are 4 and 9. So n is in between 4 and 9. But it's not technically n, it's n plus 6. So my one inequality would be n plus 6 is less than 9. And I also need n plus 6 to be greater than 4. So there are your two separate inequalities. So if I ignored this left side, how would you get rid of the n plus 6?
-6.
So I would minus 6. So I'm going to just cover this for now because I can. If I minus 6 here, I'm left with n less than 3. But I have an inequality sign here, and I have a 4. So now I'm going to minus 6 over here to the 4, which 4 minus 6 gets me -2, bring down my inequality. So now I know that n needs to be between -2 and 3. So what does that look like as a graph? Well, put -2 on the left, 3 on the right. So I need n to be larger than -2. So I'm going to open my parenthesis to the right. N needs to be less than 3. I'm going to open my parenthesis to the left. And since n is all values between -2 and 3, I'm just going to shade everything between those two sets of parentheses. So then what would that look like in interval notation?
-2, 3.
-2, 3. Perfect. Okay, so the and compound inequalities are kind of easy interval-wise because you can physically transfer it down. All right, let's do one more of those. Let's do a 1 minus 2c minus 7 less than 7. And then we'll do some practice. So what's my first move? Good. Add 7 to both sides. Well, all sides, not both sides now, all sides. So then we get 8 less than 2c less than 14.
It's not right in.
Up. Froze it. Good call. Good catch. There it is. And then I'm going to divide by 2. So then we get 4 less than c less than 7. So on a graph, we would have 4 and then 7. Parentheses or square brackets. Parentheses, shade everything in between. So interval notation would be 4, comma 7. With parentheses there. Okay? If that 2 would have happened to have been a -2, then what would I have had to have done? I would have to switch all the signs. Perfect. Okay. Ready to practice some of this?